Welcome to another presentation. In today's presentation, I would like to explain you about the important parameters which are associated with given random variables. What are the parameters that are associated with random variables? We already discussed in our previous presentations that any random variable is denoted by capital face letter, as I already explained you in last presentations. Okay, any random variable can be denoted or can be represented by a capital face letter, that is capital X, or otherwise you can take capital Y, or otherwise you can take capital Z, and so on and so forth, right? So these are the random variables. Okay, with respect to these random variables, what are the important parameters? There are the important parameters. So those are, the first one is very important, that is called as the expected value. What is that? Expected value. Expected value of random variable of, I simply can write as RV. Instead of writing everything random variable, I simply mention as RV, random variable. So expected value of random variable. This expected value can also be called as mean value. What is that? Mean value. Mean value of random variable. Or otherwise, this can also be called as average value. What is that? Average value. Average value. So these are the different names are there for a single parameter. Expected value. Okay, what is the meaning of this? So for any given random variable X or Y or Z, okay, so you can find out the expected value of that given random variable. Say if X is given, then for this X you need to find out the expected value of X, or mean value of X, or otherwise average value of X. These are the three different names, okay, can be called for this first parameter, that is called expected value. Okay, what is this expected value? How this can be denoted? Okay, so now I will explain in detail. So you follow this very carefully. So expected value. So for our convenience, I am representing, or I am considering a single random variable capital X. Okay, let us consider, right? Let us consider a random variable X. Okay, let us consider a random variable X. So with respect to X, the expected value, what is that? Expected value of random variable X is denoted by E of X. Remember this, E of X. So the expected value of random variable X is denoted by E of X, because in expected, what is the first letter? E. Therefore, it is denoted with capital E of X. So this is what the representation of expected value, or also called as mean value or average value. Right here. So the random variable, whatever we consider now, that can be, or that could be either a continuous random variable, right? That can be a continuous random variable, or otherwise that can be a discrete one also. Is it not? The discrete random variable also. So because in our previous presentation, or in our earlier presentation, I very clearly explained that, so the types of, what are the different types of random variables, or a random variable can be classified into two categories. What are those? The first one is continuous random variable, or similarly the second one is a discrete random variable. What is a continuous random variable? The continuous random variable is nothing but it is considered for a continuous variables without any discontinuities, is it not? So if the experiment or the possible outcome value of random variable x are considered for a continuous event, that is called a continuous random variable. Otherwise it is called a discrete one. That's it. Okay, therefore the random variable x, whichever we considered here, that could be either a continuous random variable or a discrete random variable. And very important thing that you need to or consider is that in continuous random variable, most of the time we will consider the integration. We will have the integration, whereas in discrete we will denote with that summation. Sigma will come actually, that I will explain in later. Okay, for continuous random variable, so in our given problem or whatever it is, the integral part will come. It is calculated whatever the parameter or expected value or any other value associated with the random variable. Okay, so we will consider the integration for solving that. And similarly, if it is a discrete random variable, we will consider the sigma. This is called sigma, or otherwise it is called as summation. Right? Now, means that what? So, means that what? The expected value can be for a continuous random variable, and the expected value can be this can also be different for a discrete random variable. If our random variable is a continuous random variable, otherwise I will write here for a continuous random variable, what is the expected value? E of x. The expected value can be given as like this. This is integral over minus infinity to plus infinity, and you write the possible outcome value of capital X, that is nothing but small x only, into its PDF, that is small f of x. Very, very important. This is the formula. This is the formula for the expected value of a continuous random variable. Right? So this is the expected value of a continuous random variable x. So for that, this is the formula. You have to consider the integration from minus infinite to plus infinite. And what is small x? Small x is nothing but the possible outcome value of x. So as our random variable is x, then the possible outcome value is small x only. If it is capital Y here, expected of capital Y, then you write to here small y. If it is capital Z, you must write here small z. That's it. So the possible outcome value multiplied with what is this small f of x? It is called as small PDF. This is nothing but this f of x. What is this? It is called small PDF. What is PDF? Probability density function. Do not confuse. It is not a probability distribution function. No, probability distribution function is something different, whereas this is called the PDF, small PDF, that is probability density function of random variable x. Therefore, for any random variable, it has its PDF, I mean probability density function, as well as it has its probability distribution function, right? Therefore, means that what? As I have explained in previous presentation, any x or y or capital Z, whatever it is, it has small PDF as well as capital PDF also. But for calculating the mean value or expected value, we will consider the small f of x. Remember that. So, integral over small x multiplied by its small PDF. That gives the answer. By using this formula, we will evaluate the expected value of any given random variable. Very, very important to consider. Right? Sometimes we will do some of the examples or previous questions which are asked in GATE examinations in our subsequent presentations. Right? So this is the mean value actually. This is one of the parameter. This is one of the important parameter of a random variable. One is the expected value. Say, this is for a continuous random variable. Okay, now if our x is a discrete one, then what will happen? What will happen? If our x is a discrete one, then the same definition is same, but the representation is something different. That's it. That's it. The formula or the meaning of the expected value of random variable is same, but we will represent something differently. So for a discrete random variable, what? For a discrete random variable, for a discrete random variable x, the expected value e of x, in both cases the expected will be e of x only, it will not change in both cases. Is it for continuous random variable or otherwise? Even for a discrete random variable, the representation or the denotation of this e of x will be the same, e of x. Now for a discrete random variable, so instead of integration you will have the summation. So sigma over this is x suffix I into p suffix I. That's it, where I stands for I is equal to sum 1 to small n, you can write anything. So this is what the formula for expected value of a discrete random variable x, right? So in discrete we will have the summation instead of integration. What is here a xi? What is xi is nothing but, so say for example, so x is a random variable. So for this random variable it can have number of outcome values. It can have, say for example, tossing of a coin. Let us say for example, tossing of a coin. If you consider the experiment, tossing of a coin is my random variable, or that event is the random variable. What is the event? Tossing of a coin. Then what are the, if you consider the tossing as a x, then what are its possible values? Either you can get head or otherwise tail. Only two options will be there. Either you can get head or otherwise tail. That getting of head and tail can be represented as small x1 and x2. Understood? That getting of, if you consider capital X as the event, tossing of a coin, then getting of head and getting of tail, you can consider anything. But we have two possibilities only. Those two possibilities are nothing but the possible outcome value of x. Understood? So those two possibilities, I am calling them as x1 and x2. Those are the possible outcome value of x. And say for example, second example, rolling of a die. Rolling of a die. So if you, the die is nothing but it has a 6 phases. It has 6 phases. Phase 1, phase 2, phase 3, phase 4, phase 5, phase 6. 6 phases will be there in die. Now if you are considering rolling of a die, if you roll that die for first time, means if you consider rolling of a die as a random variable x, then in first experiment you may get some possible value. In second experiment you may get, I mean second, if you roll the second time, third time, like that. So what are the values you are getting in that? Those are called the possible outcome values. Those are called possible outcome values of the random variable. I hope you understood, right? So okay, while solving the problem you can get in more detail. Do not worry if you do not understand now. So where x of y, so it has it can have any number of possible outcome values. Say for example x1, x2, x3. If it has 3 possible outcome values, then this means that if you expand this, summation is nothing but expansion, summation. So x1 and its probability. So in the first experiment, what is the possible outcome? So for each possible outcome value has its corresponding probability. So for the first one, what is its probability? For the second experiment, I mean second time tossing or rolling a die, whatever it is, what is the possible outcome value and what is its probability? Means that what it is, this is the probability function. P of xi is nothing but the probability function and x of I is nothing but possible outcome value. So possible outcome value multiplied by probability function. This is p of x is called probability function in discrete random variable. Don't confuse. Just I want to make you to understand the difference between what is a continuous random variable and what is a discrete random variable. Is it not? So, in continuous random variable, you will have the same x, its possible outcome value multiplied by its PDF, probability density function. Whereas in discrete one, you will have the same possible outcome value of the random variable x and multiplied by its probability function. This is called probability function. Right? This is the formula, very important formula for a discrete random variable. Right? So, this is the first parameter. I hope you understood this well, and I will finish off this presentation here and we'll continue in the subsequent presentation. There we will see what is the next another important parameter of a random variable, that we can see the variance. The second parameter is the variance, that we will see in the subsequent presentation, right? So thank you for watching.